So I decided to work a few examples from 8.1. So you should have already watched the videos that go along with this section, but now we want to work through some actual problems. And just a little quick overview, we've solved triangles in the past, but all the triangles that we've solved in the past were right triangles, meaning they had a 90-degree angle in them. But most triangles don't have a 90-degree angle in them. They could be obtuse, they could be acute, they could be scalene, isosceles, anything that doesn't have a right angle in it. We can't just simply use our trig ratios directly to solve those triangles. So what we need to do is use the law of sine. So if we have any triangle, including a right triangle, if we label the sides or the angles A, B, C, in the corresponding sides, little a, little b, little c, then sine of angle A over side A equals sine of angle B over little b equals sine of angle C over little c. So for any given triangle, that ratio will be true for each angle side pair. Now if we change triangles, if we take the same triangle and increase the size of it, or if we have a completely differently shaped triangle, then our ratios are going to change because they're dependent not only on the angles, but also on the size of the triangle because of the length of the sides. So let's start out with this one. We have this triangle ABC, and they give us two angles and a side. So all of the problems that we're going to work where we do the law of sines, we're going to have an angle side pair, meaning that we're given an angle and a side opposite of that angle. If we don't have an angle side pair, then we're going to be able to find the other angle, and it's going to have a side, we're going to know the side across from it. Otherwise, we're not going to be able to use law of sines, and that's what the next section is going to be about. So I like to begin by listing my angles and listing the sides and filling in what we know. We know that angle B is 38 degrees, angle C is 20 degrees. So since the angles inside a triangle add up to 180, we can add A plus 38 plus 20, that's total 180, and then we can solve that equation for A. So if we take 38 away, we've already used 38. If we take 20 away, we've already used 20. So we're left with 122 degrees for angle A. Also, you could add those two together, 38 plus 20, and take that away from 180, and you get 122. The side that we know is side B. Side B is 28. So notice we have an angle side pair. So let's start by finding side A. So whatever we are wanting to find, I like to put it on top. It makes isolating that value easier. So A over sine of angle A equals little b over sine of angle B. Now, hopefully you notice that's not the way I wrote over here. We did sine on top and the side on bottom. But if we have two ratios that are equal, if we flip the left side, then we have to flip the right side, and they're still equal. So it doesn't matter if we put sine on top or the side on top, as long as we are consistent. So now to get A by itself, multiply both sides by sine 122 degrees. So make sure your calculator is in degree mode, and mine is. So 28 divided by sine of 38 times sine of 122, and I get 38.6. So that's the length of side A. Now, can we get C using the Pythagorean theorem? And hopefully you answered no. Why not? This is not a right triangle. The Pythagorean theorem only applies to a right triangle. So to get side C, we're also going to have to use the law of sine. So we would do C over sine of its angle. And we could use either angle side pair we have. I like to use the one that we were given. A is rounded, so let's use this one. So B over sine of its angle. Now we can get C by itself. So multiply both sides by sine 20. Since we have sine 20 on bottom, sine 20 on top, so C is 28 divided by sine of 38 times sine of 20, 15.6. So we've solved that triangle. I'm just going to label these sides or put the numbers in for a quick discussion. Now, one thing we always should be aware of is, does our answer make sense? If 28 is across from a 38-degree angle, does it make sense that 15.6 is across from a 20-degree angle? This angle is smaller than that angle, so is this side smaller than that side? And it is. That doesn't guarantee that 15.6 is correct, but if this side were a larger side than this one, but this angle across from it is smaller, that wouldn't make sense. The smallest side always has to be across from the smallest angle. The largest side always has to be across from the largest angle. That doesn't guarantee that we got the correct numbers, but if that's not true, then we can be sure that our answer is wrong. But since we followed our law of sine, then yes, those answers should be correct. So let's work through another one. Let's do this one. Hopefully the copy's over. Ooh, copied a little messier than I wanted to copy that. Okay. So let's label angles A, angle B, angle C, and little a, little b, little a, little b, little c. So angle A is 36.6 degrees. Side, let's see, this 33, that's across from angle B. So side B is 33. 29, that's across from angle A. So that's side A. So notice we don't know anything about C. We don't know angle C or side C. So if we don't know either one of those, we can't find that next. So angle B is going to have to be the first thing we find. Now this is a situation, side angle, where it's ambiguous. Meaning, to begin with, we don't know if there's going to be one solution, two solutions, or no solution. Anytime that we use law of sine, then the first thing we find is an angle, then we could potentially have two solutions, but it's also possible that there's not a solution. So let's see why two solutions. So what we're looking for is B, so we're going to put sine of angle B on top over 33, sine of angle A over 29. And just like on the other ones, to get b by itself, get rid of the denominator. So if we multiply both sides by 33, we get sine of angle B is sine of 36.6 divided by 29 times 33. So to 4 decimals, that's 0.6785. Now, here's where we have to think a little bit. When we use our calculator to get angle B, we're going to be using the inverse sine button. And remember, when we use inverse sine, there's only one answer that we get for inverse sine. And since this is positive, that's going to be in the first quadrant. But sine is also positive in the second quadrant. And it is possible to have a second quadrant angle in a triangle. Angles in the second quadrant are, for example, 95, 98, 103, 135. Triangles that are obtuse have angles such as that. So we need to list the answer for this equation in the first and the second quadrant. So if we do inverse sine, we get 42.7 degrees. That's the answer to that equation in the first quadrant. To get the answer in the second quadrant, we use that same reference angle. That's 42.7 degrees before 180. So 180 go backwards 42.7. So 137.3 degrees is also a possible answer for B. So we know that B can be 42.7 degrees. But let's think, is it possible with that angle A for B to also be 137? And how do I know if that's possible? If when I add A in this other angle, if that's not more than 180, then that tells me I have some degrees left to use for C. C can't be 0 and C can't be negative. So if we add the angle we were given and our second quadrant answer to this equation, and that still leaves us something for C, then there are going to be two solutions, and in this case there are. So I'm going to write a second set of solutions here, and some things are not going to change. A was given to us, little a was given to us, little b was given to us. So one solution, angle B is 42.7. The other solution, angle B is 137.3. So let's solve the first case. Angle C, remember our three angles tally to 180. If I can get my calculator to work. So if we take away what we've used already, we've already used 36.6 degrees, and we've already used 42.7 degrees, so that leaves us 100.7 degrees for angle C. So to finish and get side C, just use law of sine. So C over sine of that angle C, 100.7 degrees, equals, we were given A and A, so let's do 29 over sine of 36.6 degrees. 29 and 36.6 degrees. So that'll allow us to find C. So multiply both sides by the denominator. And when we do that, for C we get 29 over sine of 36.6 times sine of 100.7, and I get 47.8. So that's not an angle, but that's side C. Notice that's the largest side, that's across from the largest angle. Now let's get our second solution. For our second triangle, if we start with 180 degrees, we've used 36.6 degrees, and we've used 137.3 degrees. And that leaves us just 6.1 degrees for angle C. So we can get little c over sine of its angle equals little a over sine of its angle. So this side goes with this angle, this side goes with this angle. So clear our fractions, or get c by itself, so get rid of that denominator. So multiply both sides by sine 6.1 degrees, so those cancel. So whatever we get here is c. So 29 over sine 36.6 times sine of 6.1, we get 5.2. Little bitty side, but that's also across from a little angle. So these are the values for our second solution. So we get one solution where our triangle looks roughly like this. This is the this probably is closer to the second solution. Well, their picture is really not to scale. Here, yeah, C is a small angle here. B is obtuse. If we take the same side and draw the same side down here, then notice this side, that's the side I'm wanting to change. This side stays 33. Anyway, these are our two different solutions here. So what I did, I changed the wrong side. This angle is staying constant. This side is a constant. I just swung this side from the wrong one. So we could have 29 here, or if we swing this out, this is the same 29 here if we extend this side. So our second solution, C is a little bit more than 90. And this is B. B is a smaller angle. So our first solution is actually this second picture. The original picture was actually from the first solution. B was obtuse and C was a little angle. The second picture, C is obtuse and B is the little angle. Again, that's not to scale, but the thing that tells us we have two different solutions is the first thing that we find is angle B. If we find a side first, there's one solution. But if we find an angle first using law of sine, there's simply one solution. Now, sometimes we can find angle B first, and as I mentioned earlier, there only be one solution. If when we figure up our second value for B, if that puts us over 180 degrees when we add that to the angle we already know, if we were to add these two together and that was over 180, that would not be possible. So in that case, we would just mark that solution out. In order to get no solution, when we isolate sine of our angle that we're looking for, if the other side is over 1, our ratio for sine can't exceed 1. So if we get a number over here that's more than 1, then that means for the given values, the given angle and the two sides, then it's not possible to get a solution.